Okay, in this section of the notes, I'm going to concentrate on doing the exercises with the summary of the derived method. Right, this is exercise set 134.3. This is the summary of the derived method. So when we do problems, we're going to be looking at this, and we're going to try to follow that. Okay? So let's do this. Start with problem number 1. Now, number 1, if you look at it, it's in the proper form. And what I mean by that, and I'll outline this for you. Whoops, sorry about that. When I say proper form, the form we can get a solution immediately to the problem. It's in this form over here. So I can immediately find a solution of the problem. All right? So looking at it, and again, I realize that one's written in terms of y. This one's in x. It's really the same problem. You need to identify the a, which is minus 24. And you need to identify the b, which is minus 72. All right? Plug it into the formula, which is what I'm doing over here. Do the arithmetic, which is what I'm doing over here. And you start to realize that was a really easy answer. It's just simply 6. So someone could say, I wonder if I could have done that doing something else. Of course you could have. For example, I think I always try the rational root theorem. So rational root theorem. We've been doing that for a while, by the way. So what's going to be plus or minus? Well, the factors of 72, that will be 1, 2, 3, let's see, 4, not 5, but 6, yada, yada, yada. One of the problems with the rational root theorem, though, is that it requires me to test them. And that might take some time. So the form is convenient. It actually led to one of the rational roots, 6. Then what do we recommend you do? Well, if you go back to the list, what we recommend you do is long division. That's what we recommend you do. All right? Let's go through the long division. But again, I didn't go through the arithmetic. You can do that on your own if you like. All right, what's a long division? X minus 6. You know what? I'm going to do a little differently. And I'm not going to do long division. I'm going to do this. I'm going to say x cubed minus 24x minus 72. Well, you know, I found a root to be 6. That means there's a factor of x minus 6. What remains a quadratic? Let me write this down for you. X squared. I don't know what the middle term is. And yes, we've done this before too. Whoops, not C, is it? Well, it has to be, what? That has to be 12, right? Why is that? I need to get x cubed, that's for sure, and I need to get minus 72, and I get those. What's the b, though? Well, let's go through it. I'm going to do it by equating coefficients. And really what I got to do is look at the linear term. So minus 24x would equal, let's see, 12x. I'm looking for the combinations that give me x, by the way. Minus 6bx. That means minus 24 is equal to 12 minus 6b. And what do you get there? Minus 36 minus 6b. That means b is minus 6. So let me get my eraser out. And I got to plug in minus 6 now. I'm sorry, 6. Sorry about that. Minus 6 times b. B would have to be 6 to get minus 36. All right, so I think I'm good with that. I'm going to kind of look at that. And then x squared plus 6x plus 12. I want to find its roots. The root of that is 6. We've already determined that. I would say try to factor it using finger numbers, but I don't think I'll ever get a 6 using finger numbers. So I'll go right to the quadratic formula. And what do you get? The opposite of the b, which is minus 6, plus or minus. The b squared, which is 36, minus 4 times a times c. So minus 48 over twice a, which is 2. Let's write this down. (36 minus 48 is going to be minus 12. So you can get 2i root 3. Divide through by 2, and what do you get? X equals minus 3 plus or minus I root 3. So I got my, my roots. There's 3 of them. One of the roots is 6. We did it by formula. We also did the other roots by formula. We just used the quadratic formula, which is a lot easier. And we got this. Let's make sure they're writing them down, by the way. Minus 3 plus or minus I root 3. We're good. I want to point out, this is a real coefficient polynomial. We're expecting to see the complex roots occur in conjugate pair. What do I mean by that? A plus bi, a minus bi. And we're certainly seeing that. Thank you. Oh, before I go, I want to remind you, my name is Ron Bannon. Email address, Bannon, B as in boy, @ nnon.us. Thank you.